Hello class, it's good to be with you. Here we're going to do StatTutor 18.1 cell phones. Now, as a big picture summary, first question is going to be an independent t-test, second question, paired t-test, third question, ANOVA. From what we've done so far, these are both going to do the t.test function, which you've already seen. ANOVA is going to introduce an ANOVA function. That's all that's new. I do want to point out that the paired t-test item, it's all correct in there, but there's a little bit of doing two different things in the Acrobatiq, so I want to clean that up some. Okay, so question one, did the students who did not do extra credit perform worse on the final than those who did? Okay, so let's take a look at the data, 105 observations. Extra credit, we've got these ones, they did it, zeros, they did not. So if you're just looking at the data, then we're going to compare the final exam scores for the ones group versus the zeros group. That's the task. Okay. In a box plot, we're going to have the explanatory variable in the second position and the response variable in the first position. Okay, standard form. If I could put that, it's just y, the response, by x. That is the standard form we're going to keep using all this tutorial. So box plot with that form, boom, I got two boxes. Can't read them quite so well, but here we go. Okay. Very clearly the extra credit group is just soaring above the other one. We're going to do the inferential stats on that. Now, Acrobatiq bends over backwards a little bit here, coming up with stuff. I'm going to clean this up. Install the Mosaic package, run this line here, and then run library Mosaic. Okay, mine's already on, but let's see, if I run it here, it says nothing because mine's already on. Now, I can do the mean command, and it's going to give me, this is the same exact, just you could copy and paste that. Gives me the mean for each group. Beautiful. Standard deviation, each group. Beautiful. Anything you want. Let's take the maximum. It'll give them the median. They're there. Okay. All these stats. Just a clean approach. That comes from the Mosaic package. Great. So let's run the t-test then. We're going to be running a t-test. Null hypothesis is the mean of the two populations are equal. The alternative hypothesis is going to say they're different somehow. Okay, and that's it. So t.test, we're going to have the y, the response, versus the explanatory here. You stick in for your mu what goes there, in this case equal to each other, 0. And then alternative, we're going to predict a one-sided prediction here that the extra credit group has higher than the non-extra credit. And we run the test. Here it is. Okay, I've got the two means. We saw those numbers before. Clearly here group 1's way higher. And the p-value is teeny tiny. That e to the negative 13 literally means times 10 to the negative 13 power. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 6, 2, 7, 1. That's the number there. I said 12 because there's one more decimal on the 6. Okay, awesome. So we've got that one nailed out. Let's do question 2. Okay, question 2, just a little warning. There's two approaches for running a paired t-test. The first approach we can think of in the data as we're looking at midterm 1 and midterm 2, and we're hypothesizing midterm 2 is going to have a lower score because harder material. Okay, so we want to compare those two. The paired t-test says, okay, great, take these guys, line them up, and then subtract. That's what diff underscore mid is. 83 minus 77 is 6. 72 minus 77 is negative 5, and so on. Approach 1, we operate just on this single vector of differences. Approach 2, equivalent. We just take both of those two midterms and use them both. Either one is correct and works. The theory in your book that you read is for the difference in the middle, but Acrobatiq in this stat tutorial, it kind of blends a little bit. Okay, I don't want to confuse the matter. So let's look at it here from the Form 1 approach. Taking those differences, here they are. We had things like a 6 and a -5. Look at that. Just left of the 0 here is the peak. So it looks like the peak is negative, near to 0. That's what we're seeing, okay? Now, the summary, we can do the summary there. The median is 0, okay, deadpan on. The mean is actually above 0. That's an indication of maybe a titch of skewness. All right. Now, let's just go right into the t-test. And since there's only one vector of data, it's basically the one sample t-test that we did in the last stat tutor, okay, 17.1. So I'm going to run that line. And looking at it, I've got the data, that's the single column of data. We're hypothesizing it's 0. And then we have an alternative of greater, okay? Get a p-value, 0.2, greater than 0.05. Do not reject the null. We say, meh, look at, that's pretty close to 0 there. No difference detected on midterm 2 versus 1. Maybe the material's harder, the students put up more work. Okay, if I just adjust the approach, then treating the two vectors as separate, we could literally look at both of their box plots. And in your box plot command, you can just enter them separated by commas, as many variables as you want, as long as they're on the same scale. Okay? Now, summary, we could just look at the data summaries by variable. So I'm just looking at them separately here. We've got the means that pop up, and that's fine. When you do the t-test, then since I have two columns now, we've got to tell the t-test function, hey, you're working with two columns, you got to do something here. And so it's called the paired argument. We set paired equals to true. And then you set in two values for the data, two variables. Okay, so that's how that works. Let's look at it. You'll notice that I get the exact same p-value, same output there. Okay, so that's, either one works. It's up to you. Let's go to question 3. Okay, question 3. Did one class perform significantly better than the other? Class, we're thinking freshman, sophomore, junior, senior. 4 groups. So now class is my variable along with final. Looking at that, here's class, here's final. So response, explanatory, typical. We're going to pop in the box plot. There it is, freshman, sophomore, junior, senior. Looks like seniors are a little bit lower, unfortunately. Okay. Now, using the same syntax from that mosaic plot, I can do the mean, the median, standard deviation, whatever you want. When you're looking at the Acrobatiq tutorial, they're using this fancy tapply command and a little bit of fancy stuff. We don't need that. I'm trying to give you a clean, concise syntax that'll handle everything necessary. And so here it is. Okay. By eyeball, yeah, we've already made our prediction that the 4th group looks like they are lower. And so we're thinking, yeah, there's differences here. Okay, going to the ANOVA. I put a little note in here. If I look at this class variable, data CLASS. Notice that we know it's categorical, but R doesn't. R sees a number there because that's what was put in. We have to tell R that those are categories. If you use a number, then you may need to do this too. If you're importing it from a .csv file, sometimes it will just automatically make it a category, sometimes it won't. There's certain conditions that it uses. It's not random. Okay, so to tell it that, we need this command called factor. So I apologize, I'm introducing a new command. Just run factor on the object you want to convert into a factor. A factor is the categorical variable, and then boom, it's in there. So I've called it C just for class. So if I look at C, notice I get the exact same output, but it says levels 1, 2, 3, 4. If I do mean of data class, I get something. If I do mean of C, it's going to say, hey, can't do it. It's categorical. Okay, that being the case then, here's our ANOVA. One single ANOVA command doesn't do it because ANOVA is related to a thing called linear models, and so we obtain the linear model and then you look at the ANOVA table. So here's the line for getting the ANOVA model. Again, response explanatory, so that's the standard thing we've been doing all along. And so out is it. Okay, it's just that. I want to see the ANOVA table on that. So to see it, we have to run the ANOVA command, and then you get your ANOVA table. We're interested in the p-value. It's small, 0.04. It is below 0.05 cutoff. So in this case, we would say we reject the null hypothesis that the means are equal. We conclude there is a statistically significant difference between some of the means. By observation, we know that the seniors have a lower value.